Hello, everyone. I'm actually very aware of mic management types of scenarios because I'm usually the guy in the back yelling, "We can't hear you." So let me know if that is the case, and I'll definitely try to fix that. My understanding is that if it sounds uncomfortable to you up here, it's probably. Anyway, as Andy mentioned, I came on with the network in April, and I'll give you a little bit of background. I know some of you here, but not that many. I have forestry training in UNB and UBC, and I also have some postgraduate work at Dalhousie. I've worked across Canada on different jobs, BC, Saskatchewan, Alberta, Newfoundland, PEI, New Brunswick, and here through consulting work, but also when I lived in various places. Most of my work here, though, has been in Nova Scotia and on and off for about 20 years at the department as a research forester, I should say, specializing in soils and site classification and that type of interpretation. I'm a co-author of the FEC guides that some of you are, hopefully a lot of you are using, or somebody's using that there. Anyway, I was very happy to come on board with the network, and I really believe in the mission that this project is pursuing, and the focus and the dedication of everybody involved. So this is a great opportunity for myself, as well as I think about general. So I'd like to just give you a few thoughts that I have on forest management in the era of climate change, and I should qualify that a little bit in the era of human accelerated climate change. There's some controversy sometimes about just the general term. And feel free to ask questions at any time, not necessarily just at the end, and go from there. And just for the record, Ryan, my presentation works on the machine, and I'm not sure if it's the software version thing or not. In the world of climate change, there's facts, there's assumptions, and there's projection. And some of these assignments of these terms are, well, they all are mine, but I'm hoping that most that agree with those. And for the most part, I think I'm not going to talk about anything that you probably haven't heard before or haven't thought about, but these are some of the ones that came, front of mind for the most. So climate change is real. Accelerated human climate change is real. I mean, that's a fact, and then it will affect different regions in different ways. That's the assumption. And also, I would say it's also, or sorry, that's projection. And you could argue this also a fact, the range of conditions you see across the country. In Nova Scotia, climate change will lead to warmer average and seasonal temperature. That's projection, and I'm going to show you some data here in a little bit that kind of supports that. It'll also lead to higher precipitation, relatively more winter precipitation, and unevenly distributed. And that's a projection. So here is a resource that if you don't know about, I would encourage you to look up. There is a product called Climate NA, standing for Climate North America. And this is a product that came out of UBC. And what they've been able to do there is take all this science and all this modeling work that's been done over the last several years and decades now, and actually make it accessible to anybody who has a computer. And anywhere in North America is covered. So they're not creating new data, they're just making it accessible to anyone who wants to look. Now they actually have a software package that you can download and do more with, but they also have what I'm showing you here now, which is their online version. And if you have a computer, all you gotta do is Google Climate NA map, and it'll take you to this site, and this is what you'll first see when you open it. And as you can see on the left-hand side, there's lots of potential data, and I'm going to show you some examples of those. So I just zeroed in on Nova Scotia on that larger North American map, and I arbitrarily picked a point somewhere in central Nova Scotia. You can pinpoint that location wherever you want to. And that is the latitude, longitude point that will show up in the data associated from the model, and actually historic real data show up. So as an example right now, this is somewhere in central Nova Scotia. I didn't actually pick a place, I just clicked on the map. And right now the default setting is the 1961 to 1990 normal data. So this is real data that was measured at different weather stations across Nova Scotia and the country or whatever. And then it's interpolated between that or where you are based on your latitude and elevation. So that's real data, but again, it's been interpolated between those measurement points. And so it gives you a whole series of what they call annual variables, seasonal variables, and monthly variables. Some of these are just derivatives of measured data. Some of them are calculated. Some of them are real. Some of them are results of calculation. So that's the data you see for the normal. What I did here then is I used the model and I just picked different scenarios and entered it into the, I'll just go back for a second. Up here, you can choose different periods of actual measured data. So we'll have right up to 2020, I believe, of measured data. And if you want to project into the future, then you go down here and you select your source of the modeling information and the level of change that's being predicted. So I did that. And so I'm showing you a table of some of the data that came out of this model for the normals for 1960 to 1990, and then for the last decade, and then some of the projections of these models. So the first projection is the best case scenario from the current modeling information, which is a blend of 13 different models. They call them global circulation models. And this is their code for the least impact, I guess, or the best case scenario of the change. And then also the worst case scenario. And so these are the actual and projected data for this sample location. So I guess the point that I'm trying to make here is that in all cases, temperatures are increasing, average temperatures are increasing overall. In some cases, it's quite dramatic. I mean, we're going from a normal in the 60s to 90s of 5 up to a projection of 9 in the worst case scenario and close to 8 in the best case scenario. So, I mean, it's a consistent and projected change for all these variables. Same with winter average, min-max. You can see also, it's interesting that maximum temperature, average maximum temperature is going to be above zero. Some of these, and actually was for the last. Same with summer. Precipitation, you can see, is also predicted to, or projected, I should say. It's not predicted, it's projected. There's a difference in the term. And you can see that's increasing, but also the winter fraction. So anyway, I encourage you to look at this site and for your own area of interest and just get a feel for what's out there. There's a help button somewhere There it is. Quick tutorial. Very simple thing to use, and it tells you what all the variables mean and everything. Very, very useful.
Kevin,
Yes.
can I ask you a question?
Yep.
I wonder if you have a sense, based upon using that tool, if we were to project ahead, 30 years, what our climate might be like, compared to some other place, like would we be like Florida or Georgia? If we could imagine in our mind what some other place in North America is like right now, and imagine what it might be like in 30 years. Could you give us a sense of where that might be?
Well, the question was about if you can use the model to kind of compare where we are or where we might be in the future to a current location's climate now. And I think the answer is, well, I know the answer is yes, you can do that. And I haven't done it specifically with this model yet, but it's easily doable. But I have read other papers that kind of, based on their analysis at the time, they were looking at the future conditions in the Maritimes as being similar to what Kentucky is roughly around now. Kentucky, Vermont, that area, I think. That may have changed from the time of that research, but it gives you an idea of that kind of latitude. But it's easily something you can do by running the model, getting the values that you can see for the area, and then comparing it to the current data for other parts of one of them. So a few of the other points, and this is no surprise to anybody, is that climate change is going to lead to more frequent and/or severe wind disturbance events and hurricanes and tropical storms, however you call them, based on the arbitrary definition of when the wind speed crosses a threshold. But either way, those are major events. But I'm also looking at it as just the kind of our typical, and well, it's not just those storm events that are need to be aware of. We had several, I think, weather events this spring, even that where the winds were gusty, for lack of a better way of putting it, and that's going to be probably more common as well. So it's not just the big storm events. We need to be, I think, concerned about just regular wind events. Number 5 there, projected changes in temperature and precipitation patterns will mean warm, wet winters and very little to no consistent, reliable frozen ground. I consider that a fact now as well as an assumption. And I don't think anyone's surprised by that. Anyone who's worked in the woods knows now that that old adage about let's wait till it's frozen before you go there is basically not even workable anymore. And I put that there for that reason, but also let you know that that is also the case in other jurisdictions, even out west where you traditionally think it's colder. They do have problems sometimes with winter thaws as well. So it's not just, in America. But I think it's a fact of life now that we can't assume that winter is a harvest season that for high hazard sites. In fact, if you're there often now, you're there at the worst time, not the best time. The other thing about spring and fall temperatures combined with that uneven precipitation is going to lead to more frequent summer drought in some areas at least. I have this down as a projection and assumption at this point, but I could argue, I would disagree necessarily that it's actually fact in some places, especially in western parts of the province. And it's when you combine this increased temperature over a longer period of time with intermittent rainfall, not steady rainfall, you combine that with your soil conditions that don't allow a lot of moisture holding capacity, that's where your drought areas are really going to stand out.
What happens if you change the assumptions? Or is there a project that changes the assumption?
Well, the assumption is, sorry, the questions about changing the assumption, that assumption is just based on the logic of the projection. So if you're projecting this condition, then the assumption is it's going to lead to higher drug conditions at certain sites. It's just part of the continuation of the logic. That's why I call it an assumption. But the projection, if those projections are anywhere as accurate, then that is a natural extension. The question about drug conditions making it hard to decompose, potentially yes. There's optimal temperature and moisture regimes for decomposition. Usually when it's warmer, it's better, but if the moisture's not there, then it's slow it down. So like everything else, it'll have a variable effect. It'll be site dependent. But these are the types of things we need to consider. And along those lines, I mean, this is one of the big things that drives this whole thing about what we do about this climate changing for forest management is that trees and all plants are adapted to a finite range of climate conditions, and also within that finite range of where they can actually grow and reproduce. It's also optimal. And that's a fact. There's no way around that. So they call these things climate niches. Sometimes you'll hear the term climate envelope. It's just an idea that there is that range and identify it. And it's going to affect some trees more than others, either because of the change itself or how fast the change. So that's the projection. So ultimately, the logic there is that you're going to have winners and losers in the tree world as climate change. And in this part of the world, the Acadian forest region area, somewhat unique in the fact that you're kind of at the southern end of some boreal range and the northern end of some temperate hardwood range. And so we have species here that, a combination of species here that are kind of, depending on which tree you look at, some of them are at near their natural range limits, either on the cold side or the side. So that lends itself to having more potential winners and losers. So on that note, here's kind of a brief summary of a compilation of studies that one of the network partners looked at, the Community Forest International. They reviewed 3 studies, one out of the Fundy Biosphere Reserve in southern New Brunswick, another one that was done for PEI by UNB researchers. They actually did a similar study for Nova Scotia. It stayed in the gray literature, but the one they did for PEI went into the journal. And then there's also a study by TFS out of Fredericton. Here's the source of this compilation. Anyway, they looked at several species, and I highlighted the ones that were kind of common to most or all the studies. And these are their projected responses or potential trajectories, you might say, with different climate change scenario. So, not surprisingly, and you've probably heard this before, is that more boreal species like balsam fir and black spruce are generally going to decline because they're going to get too warm, essentially, for them. And some of the more temperate species like red oak and red maple are going to do quite well. Some are going to be, in between there. Persevere, it's the term that they use for ones that are kind of going to be plus or minus. And then a few like red spruce and yellow birch, they have some sensitivities. And so their predicted to be still able to survive, but not in the same range that they had before. So it'll be this more isolated patchy type of distribution across. You see a couple of asterisks there, and that's because this study was, the studies that you see the compiled data for here were done at a time when, for hemlock, a delta factor. And so without that insect, hemlock was predicted or is predicted to be kind of in the middle for sensitivity. But now we have to overlay that other factor, and that's another one of the things about climate change is all the compounding influences that either sometimes offset or actually accentuate problems. The other one is the white ash, which the emerald ash coming in. So these projections for those species may be generous because of those other. I would argue too, and I'm going to talk about this a little bit later too, that Peter maple has other issues that we need to deal with as well, besides climate change. Just a few more of these statements, I guess, is that as I just kind of alluded to, we're going to have new stresses or exacerbate current stresses that we have to anticipate and or deal with as part of this change. And so that can affect vigor, and that's actually the case obviously now with hemlock, but also potentially reduce vigor sites. Number 11, I don't think we have any debate about this one. A healthy diverse forest is our best defense. It's no different than a person. The healthier you are, the more stress you can handle, the more impacts you can handle. Same with the forest. The other thing that I would like to emphasize is that we can start to manage now for these anticipated changes to make it our forests more resilient to climate impacts. Resilient, not is a term that means no. It doesn't mean no impact. It can absorb the impact. So a couple of things that kind of relate to that whole concept, and Ryan touched on some of this in his talk, is that we're going to have to start thinking outside the box a little bit, perhaps on our harvesting and silviculture techniques. And partly that's because in the ecological forestry world, one of our main foundational pillars, you might say, is that you try to emulate natural disturbance regimes, and what that has done for forest distribution and the dynamics centuries and millennia. But if your climate is changing, that also affects your natural disturbance regimes in the sense of perhaps frequency or intensity. You're going to have to kind of also adapt some of those changes into your definition of an ecological forestry. So that leads to number 14, is that we need to, I think, in some cases, accept the fact that our forests are not going to look the same. I've always been of the opinion that a healthy forest, no matter what's in it, is better than a greater forest. But my favorite tree species. So I have fondness for certain species, but I'm not married to so to speak. And I think we need to be a little bit critical in our decision making about where we want to take some stands, because we need to be thinking as well as traditional species mixes where it makes sense, absolutely, but where we might need to tweak things a bit to accept reality, then I think. And the bottom one is another. This is my last one of these. This is another very important concept that I don't think is fully appreciated even by those who use the term adaptive management. Adaptive management means you have to monitor. If you don't monitor, then you can't adapt. So that's fundamental component of adaptive management. Not only do you have to monitor, but you have to evaluate what you find after. And then you have to base your next decision on what that tells you. So I think sometimes we're too afraid to be wrong, but there is no wrong in adaptive management. What's wrong is not changing if it should be. So adaptation, this is like an experiment. This is like a big experiment going forward with climate adaptation. So we need to do the monitoring, the evaluation, and then we need to have the courage to adapt and flexibility to adapt our thinking to reflect what we found out and or changing, even more changing circumstances. And I think the department needs to learn that as well. It's a little bit harder to do in a government structure, but like Andy said earlier, we're going to be able to hopefully have input and data and science that will allow that to happen. So monitoring is a big part of the Family Forest Network project. You can only, do so much monitoring over a 4 or 5 year period, but it'll be set up for long-term monitoring, and hopefully that'll be the case. So healthy, diverse forests. I'm sure I'm not saying anything revolutionary here, but what does that mean managing for? Well, you have to manage for biodiversity, fundamental. Either maintenance or enhancement. In some cases, maintenance is it's a minimum target. In some cases, maybe fairly biodiverse site already, and you don't need to really add more to it. But in a lot of cases, the biodiversity component has been negatively affected through past management, so you might need to enhance that. Healthy soils, fundamental. This is I spent my career almost 30 years with my head in a pit for the most cases, and so I've seen soils from every angle, you might say, and healthy soils are fundamental to a healthy ecosystem. And I think this is obviously being more realized more and more, but it needs to be said. So biodiversity, healthy soils, and it's also the idea of having multiple species, is to have that flexibility as well, but also they need to be ecologically adapted to the site. So you can't grow sugar maple on a black spruce site. It just don't work. Black spruce is there for a reason. Too dry, or it's too wet, or it's too nutrient poor to support a more traditional Acadian species mix. So you don't try and do that, but you can still do things within their ecological and build in diversity that way. Same time, you shouldn't be putting Boston fir on a sugar maple site. So it's the same idea. And then also not only is it species diversity, but we need to be looking at more either age diversity or at least vertical and horizontal structure diversity. All these things are going to allow more resilience to impacts from either climate change itself or climate change influenced other stresses like insects. And finally, wind firmness. In our part of the world, wind disturbance is a fundamental, always has been, and it's probably going to be even more so, our main disturbance agent, at least in frequency. So we need to start really thinking about how to build wind firmness and resilience into management planning, and have to start that early on in the standard development process. In the network projects we're doing, we're focusing on some of the variables that we're assessing stands on and allow us to have a better feel for the current resilience, and also going forward on the monitoring factors and measure. I would argue it also means being on the look for, as landowners, especially if you're able to, walk your land regularly. Be looking for new or worsening changes in tree vigor. There could be several causes, most likely they're confounding causes. But anything that stresses a tree allows other factors to come in and make things worse. But we need to know when these changes are happening and start to ideally document them, but also start to look for patterns and early intervention if needed. And that's related to this next one, new insect and disease threats. I mean, part of the climate change impact is that not only are you changing the climate niche for trees and plants, you're also changing them for insects and pathogens. In some cases, it's going to make things worse, or it's going to make them the habitat more suitable for these organisms. And so it's not going to be too surprising that we're going to get things coming in that either haven't been a big threat before or maybe were never ever here before. Invasive plants, obviously, some of you know Nick Hill. He's one of the botanists extraordinaire in the province, and I think I can paraphrase him by saying that if you have an invasive species, then something about that site's disturbed. Those invasive species are taking advantage of disturbance, either natural or human caused, and so you need to be able to consider that climate change is a disturbance in a sense, and maybe causing conditions to favorable these invasives. Deal with that sooner or later, possibly. And then changes in tree phenology. This is an interesting one because part of the adaptability of species is also built around its life cycle. So if we start having variability in our climate, not only in trends, but also seasonal variation, what I call yo-yo weather in a lot of cases now, that's going to mix up or confuse the normal patterns of some of these physiological processes like flowering and bud set and leaf fall and whatnot. These are often associated with stuff like growing degree days. Those are just measures of ways to show, okay, how much heat has the site received this spring, and as soon as it crosses a kind of a threshold that the species adapt to, they might start to flower. But those types of things happen at different stages now because of yo-yo weather and whatnot. You might have asynchrony between some of these processes that to be more synchronous. And so there's lots of things that can affect the ability of tree and other plant species and insect relationships and all those intricate connections that have been developed over millennia that are being disrupted, cause those things to cause grief. So I would encourage you to be on the lookout, and many of you have a lot of knowledge of your sites. Start to document if you're seeing things like pollen or flowering that's happening sooner or later, frost, that type of stuff. Really is a couple. So my summary is we need both active and adaptive. That's ecologically. That would be my summary sentence. This whole rambling thought. And that includes everything. It's hard to put it all together. It's hard to think of everything, but if we kind of have that as our mindset and think of adaptation as a primary need and goal, knowing that we're going to make decisions that may not bear out in the long run as the right ones, but at the time they were the right ones, and but don't be afraid to change direction as needed. But the other key word there is active, because the changes are going to happen regardless. We can get in there on the ground floor, so to speak, and help steer the ship a little bit as much as we can, where we hope to take it. And that requires active management with an ecological focus to help build that resiliency. Well, some of the newer management options and ideas that are kind of out there, either I have newer in quotes because they may be newer for our part, but they're not necessarily brand new in forest management. So Ryan alluded to this already. These are the kind of two main approaches that are in this new silviculture guide for the ecological matrix that's been applied on Crown land. But I think it should be pointed out that this is new for the Crown as well. This publication came out 2 years ago now. And they're only now putting out trials of these treatments for research. So the province doesn't have all the answers on with the SGM. Some of the treatments in the SGM are more traditional and have been tried in the province, but some of these irregular shelterwood treatments have been applied in areas like Maine, for instance, but not in Nova Scotia. So it's a working experiment, a working document, a live document place. Yes. So we're going to be able to hopefully provide some input into that living document going forward, especially with the context of private land. Underplanting stands with lit species. Lit stands for long-lived, shade intermediate, and shade tolerant species. In other words, they can grow under their own shade, so they're able to reproduce and regenerate and grow without full light. And not all of them are long-lived, but a lot of them are. Underplanting stands with lit hardwoods. So no one that I'm aware of has done this to any large extent in Nova Scotia. Some landowners have probably done it, but on a large scale basis, it hasn't happened. But with climate adaptation and the need to restore some ecosystems back to on the trajectory that they would have been on before, prior to management or mismanagement, depending on how you want to put it, could require that type of planting to kind of jumpstart the process. And so we're going to be looking at that as part of the network treatments, sites that would benefit from a jumpstart of planting of lit hardwood species in the understory. Will be front and center on some sites, some treatments. That will include the need to cage those tree browsing, because it would be folly to put them out there and hope for the best. And so in the past, this has seemed to be very cost prohibitive and they will cost money. But if your objective is to manage these stands towards their natural climate or climax conditions, and hardwoods are part of that, then it's just silviculture. So funding. It's kind of basic. So we have to show that it'll work, and we have to show some data about the cost. Liming to offset lingering impacts of acid rain on forest soil nutrient levels, especially calcium. This is dear to my heart. I've been on this bandwagon for many years, especially in Western Nova Scotia. Our soils have been severely impacted by acid rain, and even though the deposition has gone down substantially over the last 20, 30 years, and no one talks about acid rain anymore, the impact is still there, it's lingering. The recovery has not happened. That includes stream water recovery for fish, but also forest. We've done several sampling efforts across the province to give you an idea of kind of the impact. Base saturation is a term that's used in soil science. It's meant to give you a percentage of your available cations or nutrients. It's a percentage of the available capacity to hold on to them in soils. So you have your good cations, your base cations like calcium, magnesium, potassium, and you have your bad cations like aluminum. And the ratio ideally should be a minimum of 20%. So you should be ideally having about 20% or higher base cation percent. A healthy soil. A lot of our soils are down around 5. And that is not going to change anytime soon in a lot of sites because the impact has been that long term, and the weathering process to replenish those cations will take millennia, centuries. So in some cases, we need to help jumpstart that recovery by alignment. And this is where I come back to sugar maple. I think a lot of our problems with sugar maple reestablishment is because of calcium. And this has been documented in the New England states. In fact, there are some sites down there now where they just say, this is the last sugar maple stand you really have on this site, unless you want to do something about it. Very sensitive to calcium depletion. It's known across northeastern North America. They line sugar bushes in Quebec for this reason. It's something, to me, again, it's like underplanting of wood species, liming as needed on sites. It's a silviculture option going forward in my book. But we're going to be liming some sites as needed as part of the tree. You know, in collaboration, in this case, with the Nova Scotia Salmon Association, because they're wanting to also have more upland liming to help eventually the downstream benefits. And Ryan also alluded to this treatment that's being looked at right now as we speak. Actually, a few treatments already. We can talk to him more about what this means, but you know, there's some kind of traditional windows of opportunity supposedly for PCT or pre-commercial thing that you know you get funding for to help happen. But that's always been with a timber focus on management. So if you pass that window, then funding's not there anymore. But what do you do with the site? You're going to stagnate. Take on time to get back on track, so to speak. So restoration thinning for these what are deemed too tall regenerating stands to focus more on the lift species that are there, but also I think potentially, and this is an important thing, is if we can start to build up wind resilience in these in trees from a younger age, and as they progress and more density management or they self-thin on their own, they're going to have more wind resilience if they grow up at certain spaces that allow that to happen. So I think there's a potential win-win with this treatment. And also actively managing for carbon and sequestration and storage. I was reminded yesterday that those two terms are not the same. Sequestration is actual active capturing of carbon. The atmosphere. Storage is maintaining already captured carbon. Letting that be. So there's two different definitions there. Two different possibly approaches to it. But carbon sequestration is a climate change mitigation measure, which is obviously something we all should be thinking about, but that's separate. Mitigation is separate from adaptation. No matter how much mitigation we do now, we're going to still have to adapt. Going to cross over that line. It's a question of how to adapt and come to a new steady state. So my last slide is a little bit about some of the other work that through the network partnerships, either network partners themselves or others that we're looking at. It's kind of complementary initiatives. Is that they do have formal approaches, documented approaches to do focused climate vulnerability adaptation assessments. So it's They're not as onerous as they sound, but there is a systematic approach that's been developed over the years. And I recently took some training on this from UBC online, and through that experience, made some connections with the UBC folks that are putting this workshop together. And there's some interest in having the network project and to facilitate a woodlot focused CVA down here as one of their national case study projects, trying to build up a library of assessments and approaches that are taken. So we're going to follow up with that and see if we can make that happen. And there, as part of that process, there's always going to be an opportunity for landowners. In fact, it's critical for landowners as part of the process. So you'll be hearing more about that as we. The other big one that we're trying to make happen is that this province-wide forest soil sampling and health assessment program for forest soils. A lot more interest in forest soils, as I mentioned over the years. Dalhousie AC has recently formed a Center for Sustainable Soil Management, which is not only focused on agriculture, but all terrestrial system. So they're very interested in the forest soils world as well. The province, through the department, is a founding or contributing member of that new center, and so they're building up that capacity for analysis and assessment. Research Nova Scotia has money related available for research focused in forest conditions to help the economic and long-term viability of forest management. So all these things are coming together. Large private owners have been in touch with Genome Atlantic because they're interested in the biodiversity side of how do we characterize the biological forest soil. And all these people are coming together, and there's a really good opportunity here to develop a province-wide program where landowners can be citizen scientists in a sense and sample their own soils under standard protocol, submit those soils to Dalhousie and help them build up their data set at the same time as providing data to landowners. And we see that as being something that could lead to then either a postdoc or a PhD student to start to develop management interpretations or health assessment criteria to rate current condition as a benchmark and then how we're improving it. So really pushing for that one. I hope to have some more information on that later in the summer. And Andy mentioned this one earlier, the 2 Billion Trees program. There's a national initiative that has some partners that are already in the province getting direct connection to the national program, but the province is also just signed off on our program itself. And as part of this whole wild or 2 Billion Trees program is they need seed. It's not just 2 billion spruce trees, we're talking 2 billion trees. And the idea is not only to produce or to establish more planting of trees for climate mitigation, but also biodiversity, one of the objectives. So there's a good opportunity here to start, and this goes back to that whole idea of underplanting with tolerant hardwoods. Is a connection here to take wild seed and send it off to nurseries like Strathmore, and they'll grow the hardwoods or whatever, and it'll be in-house, so to speak, and those trees come back to the woodlot owners and others. And I spoke with Simon Bachstedt, he's the tree improvement forester at the department, and I confirmed with him that wild seed collection is an important part of this. So, and there's money to be paid. So as woodland owners, if you have wild seed crops that are happening on the property, you can collect that under certain protocols and be adhere to make sure that seed is viable and whatnot, or most viable. But also you'll get reimbursed for that, and then some of those trees may end up actually come back to you. So we're gonna, as that program develops through the department, keep following that and keep that dialogue open. They're only now just hiring their coordinator to make for this project. Still early days on that, but it's a great opportunity. And I'd always encourage you to look for good crops, including white ash, any species. They're looking for everything, beech as well. Some of this is seed conservation, not just for silviculture, but just to have any good crops of any species are worth noting and letting others know in case. And that's the end of my rambling. Questions? Yeah.